Well, good morning, everyone. My name is Victor Siura, and I'm a senior software engineer at CppCon, working on the Advanced Installer team. I've been working on Advanced Installer for over a decade now, and currently I spend most of my time working with my team on improving the repackaging and virtualization capabilities in Advanced Installer, helping our clients migrate their Win32 desktop applications to the modern application model of the Windows Store, that is UWP Apex packages. To give you a bit of a context about the project I work on, Advanced Installer is an IDE. It's a Windows installer authoring tool that helps developers and IT pros create MSI, EXE, AppV packages, and Apex packages. It's a 14-year-old code base under active development, about 2.5 million lines of C++ code, 130 Visual Studio projects that include executables, DLLs, static libs. We built everything with Visual Studio 2017. We do about a monthly release cycle on 3-week sprints. We do Windows-only deployment, and we have strong Windows SDK dependencies, as our code base has a fairly wide API surface area due to our application domain, of course. Why am I here? Well, I Googled this phrase a few days back to check my spelling, and found myself looking at some really disturbing quotes. I see some of you reaching for your phones. Please don't do that. Cannot compete with this. I mean, why am I here at CppCon giving this talk? Well, our experience in adopting Clang tools in a traditionally Windows-only development environment, we've been in Visual Studio world for all our professional lives, has been a very positive experience for my team. And we are here to share some of our experiences in this journey of trying to adopt Clang tools, especially Clang Tidy. And the story I'm about to tell is about the struggles to get here, as well as the benefits we encountered and the large-scale refactorings we were able to perform with Clang Tidy once we set up everything. Just a bit of a disclaimer. This talk is not about Clang versus Visual Studio. I see some Microsoft people in the room. We're a Windows-only development team, and we're going to continue being this way. And we're going to continue using both Visual Studio and Clang tools on the side to modernize, refactor, and overall improve our code quality. A bit of a timeline. I think in this kind of talk, a case study kind of talk, very important thing is to realize the time scale in order to share the travel and the experience with you and make sure you know what you're embarking on if you would like to try something similar. It all started a year ago here at CppCon with a Birds of a Feather session on Clang format. About that time, we were thinking about adopting Clang format for our workflow, and this session at CppCon last year gave us the right motivation and experience sharing with other people here to try to tackle this on, and we achieved this at the end of last year, and it culminated with a big reformat and SCM push after endless debates on styles and configs, of course. And our current workflow is basically using Clang format via Visual Studio extension with auto format on save. That's a free extension on the Windows Marketplace. Our goals was building on the success of Clang format. We gained courage to experiment with Clang Tidy. But this is not a straight-through proposition, because using Clang format doesn't require you to be able to compile your code base with Clang. It just needs to be able to lex it, tokenize it. So embarking on a Clang Tidy trip required that Clang was able to compile our Windows code base. That compiled fine with Visual Studio, of course. Just a note, we were already on high warning levels, W4 and WX for our projects. So we were in pretty good shape already in terms of warnings and conformance. But we did encounter quite a few non-standard C++ language extensions that, if you can, people will use them. And there was quite a bit of those, and we tried to fix them and achieve cross-compiler compatibility with Clang. Of course, we intended to perform large-scale refactorings with modernized modules and readability modules from Clang Tidy, and we did all that, and also ran code analysis to find subtle bugs and fix them. Just to give you a few examples of stuff we encountered. Non-virtual destructor calls, overload function hiding base class methods, incorrect reordering of member initializer lists, pessimizing moves, and missing field initializers, just to name a few. A lot more. A lot more. A frequent offender, double user-defined conversions. We had quite a few of those, especially for strings and string literals. And we had quite a few of those, and we had to fix each and every one. Coming back to the timeline, we started playing with Clang on Windows with LLVM 3.9 in January this year. First commits, fixing, like I said, warnings and errors. And to help with that, we created a crude automation attempt with some batch files. I'll just show you one a little later to see how simple and naive that was. And after a month on this workflow, we needed to upgrade to something more powerful. And we implemented the PowerShell script to help with this build and fixing workflow. In March, our PowerShell script gained the ability to run Clang Tidy checks as well. And we did the first experiments on our source code on some core libraries. In April, after only 3 months, we were able to compile our whole code base with Clang 3.9 with some default warnings disabled, to be fair. And immediately after that, to prevent further breakage, we integrated Clang build into our workflow by creating a Jenkins job to build basically every SCM change in our code base. Later on, we did several improvements to our PowerShell automation script, like support for precompiled headers, parallel compilation, project filters, SDK versioning, and so on. And over the summer, we continued experiments with Clang Tidy on our source code with better coverage. And it's important to mention that at that time, we also upgraded from Visual Studio 2015 to 2017. And this is relevant for Clang because we also needed to update our Clang compilation scripts. We started work on a custom-based refactoring tool based on libtooling, and that helped us tremendously as well during this code rejuvenation. And we fixed Clang 4.0 issues and upgraded in July to Clang 4.0. Next, we got a little courageous and started tackling WAll warnings in Clang, quite a few of those. And we've made extensive code transformations with our custom libtooling helpers. Finally, in August, our whole code base compiles with Clang WAll. And again, we got a little courageous and started embarking on WExtra. We're still not there, but it's work in progress. And we started developing a Visual Studio extension that we named Clang Power Tools to help developers with this workflow. And over the summer, we did large-scale refactorings with Clang Tidy using modernized modules, readability modules from Clang Tidy. And we did huge code transformations with these modules. Of course, every change needed to be thoroughly inspected and tested. There were some problems with some of the modules, but overall it was a very positive experience that I encourage you all to take. So in September, we finally upgraded to LLVM 5.0 and fixed a little bit more warnings coming from that. Basically, most of them were Lambda capture warnings. And we open sourced our Visual Studio extension and our PowerShell scripts on GitHub. In September, we also published the extension to Visual Studio Marketplace, and it's a free extension you can try out for yourselves. And here we are. Some of the transformations we performed on our code base with Tidy use null pointer, loop conversions for basically modernizing loops to range for loops, use override, that was a very beneficial modernization, redundant string setter, use and place, auto, make shared, make unique, equals default, that was a big one, and equals delete. Default member initializing, passing by value, brace initialization, using instead of type defs, CPP core guidelines, readability improvements, and some string optimizations. A lot of effort was involved in examining reports from the static analysis tool in Clang Tidy and fixing some of the bugs we encountered. There were some false positives, of course, as it's expected with these kind of tools. And also examining CPP core guidelines reports as well. How did we achieve all that? Using tools, of course. Like I said, our PowerShell scripts, our custom lib tooling implementations, and our Visual Studio extension. I'm up here, but I have to give a shout out to some of my teammates that helped tremendously in this effort for developing our PowerShell scripts. I have my PowerShell wizard there, Gabriel, and our Visual Studio extension, as well as our custom tools built on lib tooling. And many other teammates that helped fixing errors and warnings in our source code. It was really a big effort. Simple beginnings. As you can see, this is how we started at the beginning of this year with some simple batch files. Very naive. We quickly came to some of the limitations on this approach. But you've got to start somewhere. And this is how we started. As you can see, it's not very fancy. After about a month of struggling with batch files and fixing issues that way, my colleague Gabriel helped me with a PowerShell script that we developed since then. It's much more complicated. I cannot fit that on the slide. Over 1,000 lines, very configurable. Over time, we added many knobs and switches to this script, and supports both Clang compile, syntax only, of course, and Tidy workflows. Works directly on Visual Studio projects. There's no round tripping in converting projects to Clang compilation JSON database or anything like that. It works directly on the Visual Studio projects or MS Build projects for that matter. It supports parallel compilation. That is a big positive fact, because otherwise it would take forever. When we started, it used to be able to run overnight, and that's it, because it's a fairly large code base. It constructs Clang PCH files from Visual Studio standard FAX files, and automatically extracts all the required settings from Visual Studio projects, like preprocessor definitions, additional include directories, SDK versions, PCH information, debug information, and so on. To give you a bit of a flavor on using the script, some of the switches are up there. I'm not going to go over each and every one of those. Just to tell you that our main script has too many knobs, so to speak. It's very powerful. So we developed what we call a bootstrapper script that you can copy and customize. We give you an example. You can copy and customize to be able to more easily use this approach in your workflow by specifying compilation constants in this Bootstrapper script and be able to run with much fewer command line parameters when running. For example, you have here a sample PowerShell script, and you give it the project's foo and bar, and you tell it to compile every source file that matches meow and apply Clang tidy fixes in the category of modernized, basically all modernized modules. This is standard Clang tidy syntax. And for a simpler workflow, you can just tell it to parallel compile every project in a current directory, ignoring projects foo and bar. Just a few examples. How would this kind of a script look like? Well, something like this. You can define constants that are specific to your project needs or for your team, like your perfect combination of Clang flags that you need. Your mileage may vary. Not everybody can use the same configuration flags, of course. Additional specific include directories, Visual Studio versioning information, and so on. And as soon as we able to compile everything with Clang, we needed to make sure it doesn't break going forward. And as I told you, we had to immediately integrate this in our workflow, and we've been using Jenkins continuous integration. And the perfect combination for using this PowerShell script, we think, is integrating in CI. And to give you an example using Jenkins, basically you have to install and configure Jenkins PowerShell plugin, if that's not already on your box, and add a build step or create a completely new job for Clang using a Windows PowerShell script task. And this is how it would look, for example. This is invoking our Bootstrapper's PowerShell script to run in parallel, and we have one ignore project that's a third-party project that we cannot make it compile with Clang, for example. This is a simple Jenkins CI integration for running your PowerShell scripts with Clang. And our recommendation is that you basically poll SEM and build every SEM change with Clang to make sure it doesn't break, and fix issues as soon as they appear, once you achieve compatibility, of course. The best part about this is, of course, when a Clang build is broken, we have a Slack bot for Jenkins, and we're immediately notified, and the person responsible will fix it as soon as physically possible. Email notification is another option, receiving a build failure with the reports and change set, and of course with a Clang error that needs to be addressed. What about developer workflow? Well, for a developer workflow, of course, you can use the PowerShell script, and we've been using that at the very beginning, but that's much more tedious, and we think a much better approach is using a Visual Studio extension, because we're living in Visual Studio, and that's the most appropriate way to deal with these things. So we think the best approach is integration right in the IDE, and we started developing this Visual Studio extension that we're offering for free, and we also open sourced. Our Visual Studio extension basically is based on our PowerShell script, but it will rely less and less on this script as we move forward. This is just our first draft. The extension is available in the Visual Studio Marketplace. You can just search for it, just search Clang, and you'll find Clang Power Tools. Install it and configure it. We expose some of the knobs our automation for Clang tidy and Clang compile. For example, Clang compilation flags that you can configure. You can configure the behavior of the compilation, as well as configure Clang tidy checks. For example, you have a full list of supported Clang tidy checks that you can run, and you can toggle them whenever you need. There is also inline documentation for switches that we pulled off from the web. So we can basically have the whole experience right there in the IDE and see what modules are you running, and you can run repeated workflows on the same settings because these settings are persisted, of course, in your IDE. So, for example, you can tell it to auto-fix issues that Clang finds and automatically fix them and reloads in your IDE environment. You can configure individual Clang tidy checks or modules, or you can even give it a wildcard check. For example, you want to run all modernized modules or all readability modules. You can also do that. How it would look like? Well, if you install to this extension, you will find it in the contextual place you would expect. For example, you can run it for a project or for a solution. You can run either compile, just syntax only. We're not emitting any object file or intermediate representation. We don't need that. Basically, the compilation step is just needed to make sure you have compatibility and you are able to run tidy. So you can compile or tidy a whole project or your whole solution, or just a single file, for example, your current editor file, or you can compile several projects. For example, you encounter, let's say you receive a broken build report from Jenkins, and you just jump into Visual Studio, go to that file that is broken, and just fix that. You can select multiple files, of course. How it looks like, we integrate with the standard output window of Visual Studio. That's where you're going to see compilation errors and warnings, as well as the error tab in Visual Studio. It's navigable, so it will jump to the right location in the source code, exactly as you would expect from a Visual Studio warning or error. And has, of course, all the standard output that you would, and diagnostics that you would expect from a Clang compiler and Clang tidy. For example, for the tidy workflow, you can see here Clang tidy analyze report, and this one is for null dereference, for example. Okay. Where can you get it? Well, the Visual Studio extension is, like I said, in the Visual Studio Marketplace. You can get it right now. It relies on LLVM for Windows, so it's not standalone. You need to have installed LLVM on your box. There is a standard distribution for Windows. Don't worry, you don't have to build it from source. There's a Windows installer kit. So it works with Clang 3.9, 4.0, 5.0. It works with Visual Studio 2017 right now, but we're soon going to add support for 2015, and if somebody is still on that version, of course. You can find all the source code on GitHub, as well as for the extension itself and for the PowerShell scripts that we provide. And going forward, we're thinking big beyond Clang tidy. As I said, we wrote custom tools that are project specific to meet our refactoring needs. We have quite a few of those, and we're still developing on them. We fixed hundreds of member initializers lists with wrong order. That was a big milestone. to achieve WOL compatibility. We removed a lot of class private fields that were unused, like references, pointers, and other scalar types. We refactored some heavily used class constructors. We changed some of our mechanisms for acquiring dependencies between us, our models, and that was quite a large code transformation that we wouldn't have been able to perform with just grep replace or stuff like that. So we actually built a custom tool for doing those refactorings. And we have even more on the way. We think we unlocked a big potential here for code transformations. I think the biggest challenge was getting here. So achieving cross-compiler compatibility was the biggest challenge. Once we achieved that, we unlocked a tremendous horizon for what we can do in terms of tooling. Once we were able to run tidy and run our custom libtooling checks on our source code, basically you're just limited by your imagination. You can do any code transformation, you can do function deprecation, you can easily change arguments and deprecate source code and modernize your application and have full control over what happens at scale. We're talking about millions of lines of code here, and some of the transformations are not trivial. You can't get away with grep replace all the time. So for our roadmap, we're working on W extra. There were a lot of issues with this set of flags. We have a few remaining issues to fix. We plan to continuously improve the Clang Power Tools Visual Studio extension and run even more Clang tidy checks, fix more issues with Clang Analyzer. This is a tremendous source of information. Some of the reports were really eye-opening for us. Just to make a clarification, we did run also run Visual Studio Static Analyzer, and for example, Visual Studio CPP Core guidelines checks. I think we can get the best of both worlds. It's not that one tool is better than the other. They just complement each other very well. So there's never too many tools you can run or too many reports you can see and too many bugs to fix. So we're going to continue using both. We're going to rerun previous checks on new code. So this is an important issue of developing a workflow around Clang tidy. Once we ran our initial transformations and our initial fixes, we need to be able to develop a workflow going forward. How we're going to use this in our day-to-day activity? How frequently are we going to run tidy checks? So we're still figuring this out and experimenting with different workflows. Of course, in order to be able to achieve this, we need to be able to compile our whole code base on each commit, on each revision with Clang. So this is a very important issue. We don't need any regression on this part. So the biggest effort going forward is investing more in libtooling and our custom checks. Some of them are general purpose, and we intend to make them open source and available for others to try out. Some of them are very specific. I think most of them you can categorize as project specific, and we're going to develop even more of those. Okay, I didn't want to go too long with what I prepared, because this kind of case study and presentation implies questions on your parts, and I just want to be able to give you ample time in asking me questions or getting an opinion. If you can line up to the mics and start asking questions. Go ahead.
Okay. How do we avoid warnings from Clang Tidy or so in third-party headers that you include and that are like pulled into the analysis by Clang Tidy?
Yeah, that's a difficult issue.
Because iSystem doesn't work on Windows. I mean,
yeah, that's a difficult issue. You basically you have to try to isolate those. So you can our scripts and extension can ignore specific translation units, for example. But in terms of headers, you basically need to do the required refactorings to minimize the impact of third-party headers that generate tidy reports or analysis reports, to be able to carve out and ignore as a very small portion of your code as you can. So we don't have a perfect solution in this regard in terms of headers. Yeah, you just have to basically try to isolate the impact of that header on a very small piece of your code to be able to ignore. Yeah. We don't have a solution for headers. Basically, with tidy, you have a transitive include of all your source code dependencies, and it's difficult to turn off errors and warnings that come from headers. Another observation I need to make on this aspect is with regards to auto fixes. For example, when you apply a tidy fix on some source code, for example, on some CPP files, it will also fix included headers that translation unit pulls. So this is something that we encountered when we tried to parallelize Clang tidy modernizations. We couldn't do that because when running in parallel on multiple CPP files, they reference the same headers, and they basically try to write over each other and corrupted those headers. So Clang tidy autofix in parallel, again, that's something we cannot do, again, because of the transitive nature of headers included from multiple CPP files. So headers are a difficult issue. Yeah, sorry.
Thank you. Hi. Actually, I have two things I want to say.
Yeah.
First, like a little background. Like I actually work on Clang for Windows.
Cool.
And when I first read the abstract of the talk, I saw that you mentioned all these PowerShell scripts, and I was like, oh, I'm going to come in here and tell him that we already have a Visual Studio extension for Clang Tidy, but it's just not on the marketplace. And so I was going to say, like, maybe you could improve our extension and get it on the marketplace. But it turns out yours is actually much better than the one that I had developed. And so I think on behalf of the other Clang for Windows developers who are in this room, I just want to say thank you because it's really awesome.
You're welcome.
So the other thing I want to say, which is actually a question, is that I saw in your configuration options dialog, you had the compiler options. And so it looks to me like you're using probably the GCC driver, and like you're just calling clang.exe. Is that right?
Clang++.exe.
Yeah. So is there any reason, or have you considered using clangcl.exe? Because then you can actually, you don't have to pass any extra compiler options. You can just pull the MSVC compiler options from the project file and just use it.
Yeah, that's a good question. We did try that, but in the end, we just wanted to have full control over the compilation flags and be able to experiment with different compilation settings. So the reason we took this route is because we wanted to keep control, basically. Yeah, that's an option we are still looking at.
Okay.
But we prefer this route because we wanted to be able to very fine tune compilation settings and be able to experiment with, like I said, with W extra, and we even tried some warnings that are not in W extra, but we consider they're useful. So we wanted to be as generic as possible and not use any magic, so to speak. Yeah. In terms of the extension, I'm not sure exactly what's the best approach here. Maybe a unifying approach of contributing to a single extension and making that available in the Visual Studio Marketplace, maybe that would be a better approach.
Yeah, I'll probably just delete mine.
Don't do that. Maybe we can combine and get best of both worlds. So we think it's important to get it out there. That's why we open sourced it. We welcome extensions from anybody who can contribute. But we think it's important to be visible. People, when they're going to search for this kind of extension from within Visual Studio Extension Manager, they need to be able to find this and be able to run as quickly as possible. Yeah. So we're going to continue to invest in this. And I think we can benefit from many people's ideas. So your ideas are welcome.
Okay.
Thank you.
And I'm on the other end. I'm like you. I looked at Clang Tidy about 3 years ago before it was available on Windows, and I've got a code base that's much bigger than yours. And anyway, I did not succeed. So thank you for pushing this through. This looks fascinating.
We didn't think we were going to succeed either.
So does the extension go to the VCX proj file and go pull in all of the current flags and so forth and translate it right in real time there?
Yeah,
there's a JSON file that has to get generated, right?
No, I alluded to this earlier. Maybe I went too fast. We're actually not doing any round tripping in converting your Visual Studio VCH project file into a JSON Clang compilation database. We're not doing that. We're actually working directly on MS build configuration file on your Visual Studio project file directly. We're actually the script actually pulls information from that project file directly. Some of the required information needs extracted from there. For example, SDK versioning, target platform. Additionally, include directories, PCH information, Unicode information, preprocessor information, and stuff like that. Still a lot more to do in this area. More information can be automatically extracted from there, and we can do more in mapping specific Visual Studio compilation settings to Clang settings. Some of those right now are just knobs that you have to figure out how to configure. We did quite a few of effort in this part, with lots more to go. Right now, our Visual Studio extension actually relies on this PowerShell script. It has it in the box, so to speak. Going forward, we plan to rely less and less on this PowerShell script and leverage some of the integrated SDK that a Visual Studio extension has to be able to extract more information from the project and from the current editor context. For example, we're thinking about even integrating in the editor with IntelliSense-like features, or more code navigation stuff, or more on the lines of auto fixes for Tidy. So right now, we are heavily dependent on the PowerShell script because we started that way when we thought the best way to achieve publications with this extension is to just leverage the script we already had, because we started with the script. And we continue to consider that continuous integration is a very important aspect of this. So we're not going to deprecate the script once we improve the extension. So the script is going to improve as well. But the extension itself will rely less and less on the script file actually pulling information from the VCX project file, and it's going to figure out lots of the settings from the environment itself using the Visual Studio SDK.
And one more quick thing. A couple of years ago, when I looked at Clang Tidy, there were like 3 levels of transformation. There was a totally safe, something that might break the code, something that probably would break the code. Is that in the options?
That depends on the check you select. Not all the checks are configurable. Some of the checks are configurable. For example, loop convert with range for loops. Those have the exact same labels we mentioned, like safe, unsafe, and experimental or something. This is something we're not currently exposing right now. We basically run with the checks default option. So, but we do plan to expose that.
I'm just wondering what your experience was on your code base in terms of errors generated when you did some of the more aggressive transformations.
Good ones and bad ones. I can give you a few examples. I didn't want to pick on Clang Tidy, so this was mostly a talk about experience, a case study, and didn't want to show bugs or issues. But we encountered quite a few of those. For example, the loop convert tidy check was quite a good one and a decent citizen. We did the default checks. We also did some of the unsafe transformations, and it was pretty good. The result was pretty good. Very few issues. For example, other extensions are not very safe to run. For example, using was a particular check in Clang tidy that caused lots of trouble for us. First of all, it didn't catch all the type defs that it's supposed to catch, and it messed around with some of our function pointer definitions using type defs. We had some issues there in terms of we were using custom calling conventions like standard call, and basically the function pointer syntax just screwed up that tidy check. So we had some issues. Some of the checks were very nice, and we didn't have basically any problem. It generated huge diffs in our code base, but basically were just mechanical replacements or very clever replacements that were basically zero errors, zero problems that we detected. Some of them are tricky. For example, removing redundant C_str from W string. Some of them were tricky. In some places, people relied on a null terminated string being passed in, so we needed to be very careful in removing those. So overall, the experience was very nice, but you need to be very careful, and your mileage might vary. So it's very tricky, and you need to examine each and every change very carefully before you push it in.
Yeah, great. Thank you very much.
Yeah, his question touched on what I was going to ask, which is how did you go about validating the changes that Tidy made to ensure that they weren't breaking something subtle? How was your regression test coverage and such?
Basically, you have to be very careful, and of course, you rely on unit tests. That's very important. Some of the transformations were just plain breaking the build, so that were immediately spotted. But some of the stuff was silent. Like I said in the example with W-string C_str, we found some of those just by examining the diff. So you're doing large-scale code transformation, and that spares you the time of actually doing it yourself. But that doesn't preclude the fact that you need to analyze the results carefully before you push them in. So you cannot blindly just trust the tool that it will make the things right and just commit everything as it is. So we actually did careful examination line by line for each diff that the tool generated. So, and of course rely on your unit tests, but it depends on how good your coverage is. So you just need to be very careful. It's a very powerful tool, but you don't have to trust it.
Right. Would you say you have good test coverage? You're pretty happy with your
coverage? But you're never
you're never
covered.
fully satisfied.
Yeah.
And how long does your system take to build?
Sorry?
How long does your system take to build?
On Clang or on Visual Studio?
Visual Studio.
On Visual Studio, debug build is about 40 minutes. Release build about an hour.
Okay.
Yeah. And on Clang, about 45 minutes. But on Clang, we just use F syntax only. So we're just parsing it. That's it. About 45 minutes in parallel. Our Clang script basically saturates all the cores. So that is another issue that we need to address in continuous integration scenarios. We did priority queues for Jenkins jobs, because when a Clang build triggered, it basically saturated all the cores on our build machines, and other jobs were not able to perform as well. So Clang build runs pretty as fast as it can. So it's basically saturates your machine. Yeah.
Okay, thank you.
Well, first of all, thank you very much for the tool. I just can't wait to try it out on our projects. It's really awesome. All this awesomeness is available when you actually make your code compilable under Clang, right? So as you said, it took quite a lot of effort to actually make it compilable.
Yes.
And before you make it, you cannot use Clang tools to help you transform the code.
It's a catch-22, yeah.
Right. So maybe there are some tricks that you use to actually make to help yourself to make this code compilable.
Yes.
Which are those?
It's a multiple phase process. So first of all, you must be able to compile your source code to be able to run tidy. But you don't have to be able to compile it with all the switches on. You can disable a lot of warnings initially. And basically, the Clang tidy is able to work as soon as you don't have any errors. We actually have a switch that treats Clang warnings as errors, but you don't have to do it right away. So you can disable a large amount of warnings initially to be able to just make it compile with Microsoft compatibility switches. You just have to make it compile without errors. That's the first step. Without that, you cannot run tidy. But after you do that, you can run tidy modernizations and even lib tooling stuff that you develop to make it work. And we actually did that. For example, member initializer list reordering. That was a very sensitive issue that we actually couldn't perform by hand because it's very difficult to check the correct order where classes had tens of members. So doing that over millions of lines of code, it's basically impossible. So we actually did that with our with a custom developed lib tooling tool that we developed. So before achieving tidy compilation without errors, basically you just have to rely on transformations that you do by hand or with grep-like replaces, or it's a catch-22 problem. It's difficult. Yeah, but it's a multiple phase process. So you do modernizations and you were able to flip even more Clang switches. You enable warnings that you initially disabled, do more fixes with tidy and lib tooling, enable more warnings. So it's a multi-stage approach. So
yeah, just need to start. Another question you mentioned, there is an extension Clang format, right?
Yeah, that's not ours,
right,
but we use it.
So the question is, does your extension actually supersede this Clang format extension?
No, but version 1.0 of our Clang Power Tools extension doesn't call format, but this is the first thing we're going to implement in our next version is automatically calling Clang format after we tidy with autofix. So because we actually did that in our scripting scenarios, we actually did tidy transformations, and right after that we did Clang format on those transformations too, because those transformations don't format the code like you would expect. So they do surgical replaces, so to speak. So you need to rerun Clang format. So not in version 1.0, but in version 1.1, let's say, our extension will supersede Clang format. Basically, for tidy scenarios, for your day-to-day editing scenarios, I think you would be better off using the Clang format extension. They can live side by side. I actually have both of them installed on my box. So for day-to-day editing, I think the experience in Clang format extension that's already for a year in the Visual Studio Marketplace, that's very good and very simple workflow. We actually use auto format on save and everything. It's great. But for tidy scenarios, our extension will provide the format for you, if you'd like. And will pick up your configured style or whatever you have in your project.
Thanks.
Yes, my question is about, you give us your timeline, and there was multiple people involved, but in terms of workload, like, was it full-time for some of them? Was it?
That's a very good question. I wanted to mention that and I forgot. It started as a hobby project for me. And very soon after that, a colleague decided to help with the PowerShell scripts. And as soon as we got the ball rolling, more people pitched in to help. It was totally a 20% effort, so to speak. So it wasn't a goal for us. It was something we would like to see. And basically, we just convinced people to come help. So they saw what we were doing. They saw the commits and the changes. They said, interesting. You fixed that. Why did you fix that? I explained the warning or the issue that we encountered. We piqued their interest and they pitched in to help. It was not something we decided to work full time. We did this as we worked on features for our commercial product. So we did this work. Another important aspect is we did this work on our trunk. So we didn't split a branch that we fixed issues on and synced with our production environment. That would have been a total failure, in my opinion, because they would have quickly gone out of sync and people would ignore that branch and the build would continuously be broken. I cannot fix all the issues myself. So, so we did this live as we worked on developing features for production. So a few people helped. It's not a one-man job.
Okay, thank you.
Yes, my question is, I was wondering if you have any metrics that would prove that all the effort that you put in was worthwhile at the end.
One metric I can give you, my colleagues are very happy with the code transformation. I think it's a good metric. It's not something in terms of return of investment or something like that, but if people are happy and they like the result, they like looking at modern code, if you don't have any contention and debates about the review process on those changes, people rarely had any objections on the transformation we were able to perform with Tidy. So if people don't have any issues with the diffs in themselves and they're happy with the result and they pitched in voluntarily to help with this process, I think that's a very good metric.
Was that your original plan, that you just wanted to run it so the code looked better, or were you running it to fix bugs that you didn't know you had?
It was a multi-pronged approach. So we basically wanted both. We wanted to modernize our code base as well as run analysis. I was very impressed with other talks I saw about using analysis on code bases and finding bugs. And we did experiment with Visual Studio Static Analyzer, and we were happy with that. And we were interested in running more CPP core guideline checks in Tidy. So we had many goals, but it wasn't something that we scheduled. It's something that happened as we started, like you saw, we started with the batch files, we started fixing errors, people got interested. We were reading up on the reports and studying the subtle issues. So,
do you have any gut feeling for whether you think the code is more stable?
I wouldn't say that. Yeah, I wouldn't say it's more stable. Yeah, that's we had issues. Like I said, we uncovered issues. Some of them we caught before we committed. Some of them we caught in testing. And I'm not going to pretend this will improve your code. Maybe this process will also add some bugs. Yeah, we have to be very careful. But overall, we're very happy with what we did, and we don't have any regrets, and we're going to continue doing it. So,
okay,
so
thank you.
At the scale that you're working millions of lines of code, that seems pretty big for Visual Studio. I was just wondering if you could talk about your experience with that.
We don't have any issues on that scale. We don't have all the projects in a single solution, if that's what you're referring to. We have several solutions. I think our biggest solution has about 40 projects in it, but we have many solutions. We have about 134 projects overall. We don't have any issues with the IDE itself on this scale. We're happy with it. Especially in the latest version of Visual Studio, 15.3 with a lightweight solution loader. It actually loads very fast, even if you have many projects in one solution. So on that front, we're happy with it.
Thanks.
Hi, you said that you were doing all the work on your trunk. Did you have any other branches active at the time, and did you have any issues merging?
Yeah. Yeah. I was hoping to avoid that. Yeah. Like any refactoring you're gonna have issues with active branches when merging. So yes, we had issues when we actually fixed some stuff and some teammates reintegrated a branch, and we had to basically they had merge errors, and they solved them by using their version. So we had to reapply, and we think it's the right approach because they cannot redo their work, but we can rerun our tools. So the right approach in resolving merge conflicts would be accept the changes that are actual code changes that people do when integrating it, and rerunning your tools, because rerunning tools is easy. making a developer rewrite its code, it's not something you can expect. So we did have several issues like that. But we basically reran our scripts, so everything worked out.
Oh, very good. Another question I had, what was the most surprising bug or error that you saw after running something that you thought would be fairly safe?
Use using. Use using seems like a very trivial thing to modernize. And, sorry? It seems like trivial, but it messed up our whole code base. Yeah, didn't pick up all the type defs, messed up our function pointer definitions, had issues in type defs inside template functions where it actually replaced, when it replaced the type def with using, it actually replaced with a concrete type of that template instantiation instead of maintaining the template parameter. I think it's the most buggy check in Tidy.
Create bug reports for that?
Not yet. Yeah, we're gonna do that. Yeah. Actually, at least on Windows, in Clang 4.0, it actually crashed this Tidy. So in 5.0 it works, but we had several issues, and it was surprising because you asked about a surprising scenario. I thought that would be a trivial transformation, using, but it wasn't.
Thank you.
Thank you for the talk and for the courage of, expressing it and bringing it. The question is, your code, when you build it for production, what compiler do you use?
Visual Studio 2017.
Okay.
15.3 right now.
Okay.
Yeah. So
even though you are using the latest Visual Studio, I mean.
Yeah,
okay.
it's
15.3
is the latest Visual Studio version. Visual Studio 2017.
Oh, I'm sorry.
Its version number it's 15.3.
Yes.
It's Visual Studio 2017. Yeah.
When your Jenkins.
But sorry, we don't actually ship anything if the Clang build is broken.
Okay.
So the Clang build is always clean.
I see. Yeah. So you're building it with both, but you're shipping it with Visual Studio.
We don't have any plans to ship. I read a blog post about Chromium on Windows and their plans to use Clang on Windows to build. Up until now, they used Visual Studio Compiler to build their Windows flavor, and they plan to build it using LLVM on Windows. We don't have any plans on that front. Okay. We're happy with our current toolset. We just need to use the best of both worlds.
I gotcha. When you use your Jenkins on the continuous integration server, how do you actually, what you actually do to build it? Are you running your PowerShell script?
Yeah, I can show it to you again. Here you go. The workflow is add the build step of type Windows PowerShell. That's a plugin for Jenkins. Okay. It's a maybe you already have it in your Jenkins box. Otherwise, it's in the Jenkins gallery. So add that PowerShell plugin. This is the one, PowerShell plugin. So add a build step of type Windows PowerShell, or just create another job. We have a different job. We have a Jenkins job for Clang builds. It's a separate job. But you can add it as a build step post your regular build in the same Jenkins job. And the script, here it is.
Okay.
This is our bootstrapper script. AI comes from advanced installer. It's not something with artificial intelligence or anything.
do you build in Jenkins for production too with Visual Studio?
For release candidates, not for the actual RTM or Goldmaster that we ship.
Okay.
But for release candidates and QA testing, we build that in Jenkins as well.
And was what? Was Makefile or?
No, we actually use MS Build files.
MS Build. Okay.
Visual Studio projects are basically MS Build files. So we, as you saw this Windows PowerShell build action, there's a MS Build. I think you can see it here. Yeah, the second one. The second one. That's an MS Build action. And you give it the project file and it builds it for you.
Gotcha. So the last question. I'm not using, unfortunately, a Clang Tidy here. And my question is, if I want to replace not the using or other regular statement, but one function with another one, for example, I'm deprecating something. So is it possible, and
Yes.
how feasible it is?
Yes, you have to build a custom lib tooling for that. Tidy doesn't do refactorings like that.
Lib tooling.
Lib tooling is a C++ library from LLVM. You build your custom tools on top of that, and it exposes full AST, and basically you can do anything. Okay, thank you very much. The session is over.
Can I say one more thing?
Yeah.
There's a bunch of other Clang tools that are built on lib tooling already. There's like
Yes.
Clang rename that will rename variables across
Yes,
your
yes,
project. And there might be one that deletes a function. I'm not sure, but there's lots of refactoring
I wasn't
tools.
sure about the answer, but there are several tools. Catch me in the hallways. If you have any more questions, I'll be here. I'll be happy to answer any of your questions.